In this video, let's see the first numerical problem based on the concept of higher order derivatives. Now, we already know what are the notations of higher order derivatives. We are just going to see the first numerical problem, which consists of two problems. One is based on the product of x and cos x, the other is based on the logarithmic function. So, the question says, find the second order derivative of first part and second part. Let's start solving it. I write the heading as solution. Second order derivative has been asked. Now, second order derivative has been asked means the first order, if said dy by dx, the second order would be d2y by dx square. So, let y is equal to x cos x. Then what is dy by dx? dy by dx is nothing but obtained by the differentiation of y with respect to x. And this dy by dx will not be our final answer at all, because this is the first order derivative. We have to find out the second order derivative, so you have to differentiate again with respect to x. But first let's find out the first order derivative. So the first order derivative, if it is the product of two terms, apply the product rule. Leave x as it is, the differentiation of cos x is minus sin x, plus leave cos x as it is, the differentiation of x is 1. So it becomes minus x sin x plus cos x. But this is what kind of differentiation? This is only the first order derivative. Let's find out the second order derivative by again differentiating with respect to x. So for that, you have not to see y, you have to see dy by dx and then again differentiate it with the help of with respect to x. So this is the product of two terms, outside is minus, let's take minus outside. Again apply the product rule to x sin x. So leave x as it is, differentiation of sin x is cos x, plus leave sin x as it is, differentiation of x is 1. So it becomes like this. Then plus cos x means differentiation of cos x is minus sin x. Let's now expand it. It becomes minus x cos x. Then it is minus sin x which is minus 2 sin x. Now don't get confused. Now this is the final answer because we were asked about the second order derivative and d2y by dx square is the second order derivative. So this is the answer of the first part. Let's move to the second part. I hope you understood the first one. The second part is about log. So it is log x square upon e square. Let's give the heading second part. We are doing the solution of the second part. Let's make it a line for separating the first and the second. Now let y is equal to the given function log x square upon e square. Now you know one thing, log m upon n is equal to log m minus log n. So that we can do, we can actually make the question something like this. So it is log x square minus log e square. Now the base can be of our choice, right? So if the base is e both sides, if I take the base as e, what happens? You see this remains log x square only, but here it becomes what? If here it is e, log e base e just vanishes, so only 2 is left. That you know from the properties of log. Now basically my question is this and not the above one. Now you have to differentiate it first time and second time in order to obtain the second order derivative. Easy, right? So if y is given like this, what is my dy by dx? dy by dx is nothing but the differentiation first time of y with respect to x. Differentiation of log x square. Log's differentiation is 1 by x. And x square's differentiation, because it is this chain rule, first you saw log, then you saw x square. X square's differentiation is 2x minus 0, because constant's differentiation with respect to x, 0. You see anything cancels? X would be cancelling with x square, 1x goes, so it becomes 2 upon x. Or it is 2x raised to the power minus 1, that's done. Can we leave the answer here? Not at all. Why? Because this is the first order derivative. Let's differentiate it to the second time to obtain the second order derivative. So it becomes a differentiation of 2x raised to the power minus 1. 2 being a constant, don't disturb it. X raised to the power minus 1. What is the differentiation? It is minus 1, x raised to the power minus 1 minus 1. You know the power formula, right? So the answer is minus 2 x raised to the power minus 2, or in short it is minus 2 upon x square. That is the answer. So we saw two questions in this video. I hope the concept of higher order derivatives is clear now.